Hi students. Now I am going to discuss the problems that were given in 4th September 2020 JEE Mains Shift 1 students. If you observe all the problems carefully, all are given concept oriented. The students who are perfect with basics, particularly basic things. So such students can do these papers easily, students. Now let us have a look on this question paper, students. Now see the first question. Integral x square upon x sin x plus cos x whole square dx. This problem is a simple twist kept in the problem, students, regarding integration by parts. So how to crack this problem carefully, you see. So students, what I am going to do is I am going to write x square upon x sin x plus cos x whole square like this, students. I supply cos x. Carefully, you see. Okay, students, what I have done is just I have supplied cos x, multiplied and divided by cos x. This x square I have written as x into x. This x sin x plus cos x whole square I have kept in the denominator of the second function. Now for me it is first function and for me it is second function. Why I have taken x cos x here? See students, d by dx of x sin x plus cos x is going to be, carefully watch, sin x plus x cos x minus sin x. Then you will be left with what? X cos x, students. Means the derivative of x sin x plus cos x is x cos x, which is there in the numerator. So to take that advantage, you know 1 by x square formula minus 1 by x. So if you treat this as some t, this is dt, 1 by t square dt. So integration of that particular function is very easy, so that I have chosen that particular function as second function. Now shall we perform integration by parts? Now it will be first function into integral of the second function. Integral of the second function means what, students? If you treat this as a t, it is 1 by t square. 1 by t square dt. So minus 1 by t. So minus 1 upon x sin x plus cos x. Okay, students. Minus integral of, what is the formula? Derivative of the first function. Let us do x by cos x in u by v formula, students. So it will be cos x into v u dash minus u v dash by v square, you know. So cos x into 1 minus x into minus sin x upon cos square x into your previous value, students. What is your previous value? That is minus 1 by, means integral of the second function. This I have to keep there. Minus 1 upon x sin x plus cos x dx. Okay, students. Then you will be left with minus x upon cos x of x sin x plus cos x. Okay, minus of, students, what is this? X sin x plus cos x upon cos square x. This minus 1 upon x sin x plus cos x dx. This will be cancelled out. Then you will be left with minus x upon cos x of x sin x plus cos x, minus into minus plus, integral 1 upon cos square x means integral secant square x. Straight away shall I write tan x plus c. students, that particular value I have got. Later, simplification is my task because they gave all options in terms of sine and cos only. Okay. Now, let us write it like this. Minus x upon cos x of x sin x plus cos x plus tan x can be written as sin x upon cos x plus c. Okay. Now, students, you will be left with, carefully write, cos x into x sin x plus cos x. Then numerator will be minus x plus sin x of x sin x plus cos x plus c, students. Then what is happening there? Carefully you have to observe, students. I have taken this. So sin x into x sin x plus cos x is coming there. Finally, x sin x. So how to get the final answer? It is a simple step. Watch carefully, students. So students, what is happening there? Directly we can get the answer. That is minus x plus x sin square x plus sin x cos x upon cos x of x sin x plus cos x. That is nothing but, students, sin x cos x minus x of 1 minus sin square x upon cos x of x sin x plus cos x. Then what do you have, students? That is nothing but sin x cos x minus x cos square x upon cos x of x sin x plus cos x. Now, if you take cos x common, you will be left with sin x minus x cos x upon cos x of x sin x plus cos x plus c. So don't forget plus c, students. So after cancelling this, final answer is sin x minus x cos x upon x sin x plus cos x plus c. So sin x minus x cos x upon x sin x plus cos x plus c, students. So which option? Sin x minus x cos x by x sin x plus cos x plus c. So answer option 4 is the correct, students. See this problem, students. Very interesting problem, isn't it? Watch, students. Students, next problem. Two poles AB and CD of height 15 meters and 10 meters respectively are there. A comma C are on level ground. AD and BC intersect at P. Then height of P is, this is the problem given, students. It is a numerical type problem given from the sources that we have got on memory based retention. Now see, students, how to crack this problem. First of all, AB and CD. Okay, now watch the figure carefully. So I take AB figure, AB pole like this and CD pole like this. So they give these lengths as 15, 10. Clearly they mentioned that, see here, A comma C are on the level ground, AD and BC. Okay, students, now shall we join these two? And if you join these two, What is happening there? Carefully observe. This level ground, horizontal. Nice. Now they intersect at P. Now you are asked the height of P, means at what height it is located from the level ground. That is the problem, students. So see this figure carefully. Interestingly, this problem is given with a simple twist based on similar triangles, students. I take this is some x, this some y. Okay, watch. Let AQ is equal to x and CQ is equal to y and PQ is equal to H. Our task is H, students. So your goal is H. Then how to crack this problem? See, students, from first of all, from this side you see triangle AQP and see this triangle AQP and triangle ACD are similar triangles. So what I am going to do is, this is H I have taken. Therefore, I am going to take x by h. I am taking proportionality of the sides. You already know that. In case of similar triangles, what I am going to do is, it is nothing but x plus y upon 10. This is result number 1, students. Next, this side you see, students. Similarly, triangle CQP and triangle CAB are similar. Students, see this CQP, see the pointer here, CQP and CBA triangle, okay, are also similar. Then what I am going to do is y by h is equal to y plus x by 15. Equation number 2, students. Don't forget, your task is finding the value of h. Over answer came, students. Therefore, 1 plus 2 implies x by h plus y by h is equal to x plus y of 1 by 10 plus 1 by 15. Or students, then you will be left with what, students? If you take here 1 by h common there, x plus y is equal to x plus y of this. H value 6 is coming, students. Answer is coming, students. Carefully note down, students. Students, next problem. If u is equal to 2z plus iota upon z minus k iota, where z is equal to x plus iota y and k is greater than 0, curve real part of u plus imaginary part of u is equal to 1 cuts y-axis at 2 points P and Q such that PQ is equal to 5. Then the value of K is dash. This is the problem, students. We have to find the value of K. So how to crack this problem? Carefully observe. Really, it is relatively a good problem, students. A little bit lengthy problem. Carefully you watch, students. U is equal to 2 of, I am going to replace z by x plus iota y. They clearly mentioned, even if they don't mention like this, generally in geometry related problems in complex numbers chapter, we take z as x plus iota y. Then only particular locus will come. So to handle all such locus type of problems or geometrical linked problems, so we replace z by x plus iota y. So 2 of x plus iota y plus iota by x plus iota y minus ki students. Okay, now what I am going to do is just I regroup the terms. Here real part is 2x plus I of 2y plus 1 upon same x plus I of y minus k. So students, 2x plus I of 2y plus 1 upon x plus I of y minus k. We know that every complex number can be shown as a point in orthogonal plane. Okay, therefore it will be u is equal to 2x comma 2y plus 1 upon x comma y minus k. Students, we studied a formula a comma b upon c comma d, division of two complex numbers formula ac plus bd upon c square plus d square comma bc minus ad upon c square plus d square. So with the help of this, I am going to find both real and imaginary parts. Therefore, u is going to be, so carefully write students, 2x square plus 2y plus 1 into y minus k, ac plus bd upon c square plus d square, x square plus y minus k whole square students, comma bc minus ad. Okay, so it will be x of 2y plus 1 minus 2x of y minus k upon x square plus y minus k whole square. So this problem is coming like this, students. Now your task is real part of u plus imaginary part of u is going to be 1. So students, carefully watch. Real part is 2x square plus 2y plus 1 into y minus k upon x square plus y minus k whole square, and imaginary part is x of 2y plus 1 minus 2x of y minus k upon same denominator x square plus y minus k whole square. Now given that real part of u plus imaginary part of u is nothing but 1. Okay, now it will be, students, 2x square plus 2y plus 1 of y minus k, as the denominators are same. Okay, plus x of 2y plus 1 minus 2x of y minus k is going to be x square plus y minus k whole square, students. X square plus y minus k whole square. Now in the data it is clearly given that this curve, real part of u plus imaginary part of u is equal to 1 curve, cuts y-axis at 2 points, that they are p and q, and pq distance is 5. Any curve, for any curve to cut the y-axis, the necessary condition is x is equal to 0. Okay, now put x is equal to 0 since this curve cuts y-axis at 2 points, say p comma q. Now I am going to have a quadratic equation in y, students. See, I am going to put x is equal to 0 now. Now you will be left with 2y plus 1 into y minus k. This is 0, this is 0, that is also 0, is equal to y minus k whole square, implies y minus k of 2y plus 1 minus of y minus k is equal to 0, students. Then just I will simplify that to some extent. What is that? Already I told you we are going to have quadratic in y which gives two values of y which are acting as ordinates of the points p and q. For both these points, abscissa is 0 because they lie on the y-axis. So you will be having like this, y minus k into, what is this, students? 2y plus 1 minus y plus k is equal to 0, implies y minus k of y plus k plus 1 is equal to 0, students. Y minus k of y plus k plus 1 is equal to 0. Therefore, y is equal to k, y is equal to minus of k plus 1. Okay, students, implies p is equal to 0 comma k, q is equal to 0 comma minus of k plus 1. Also given that PQ is equal to 5, students. So I am going to measure the distance between P and Q. See the ordinates, students, here. Minus k plus 1. This is minus of k plus 1, that is k. So finally, what is coming there, students? 2k plus 1. Of course, I have to take modulus, students. So modulus of 2k plus 1 is equal to 5. Implies 2k plus 1 is equal to plus minus 5. So 2k plus 1 is equal to 5. On the other hand, 2k plus 1 is equal to minus 5. Here, k value 2 coming, students. Here, k value minus 3 coming. But once see the data, students, they clearly mentioned that k is greater than 0. Since k is greater than 0, k is equal to 2 is accepted. Therefore, k is equal to 2 is the correct answer, students. See the problem, students. Very nice problem, isn't it? Carefully note down. Students, next problem. The probability of a man hitting a target is 1 upon 10. Then the minimum number of trials, so that the probability of one success is at least 1 by 4. See, students, simple problem based on binomial distribution. So whatever the comment made in the problem, we have to take that particular event as success. So hitting the target is a success. So students, how to crack this problem? Carefully you watch. So here, hitting the target is success, students. So P is equal to, already probability of success given in the data itself. P is equal to 1 by 10. Obviously, Q is 9 by 10. You know that probability of failure is denoted by Q, and probability of success is denoted by P. And P and Q are complements to each other. Their sum is 1. Okay. Now, what is our task now? Our task is N, that to minimum value of N, how much? Okay, students, now read the data. The minimum number of trials, so that the probability of one success is at least 1 by 4 over. So given that probability of at least a probability of one success. So carefully you have to watch, students. Probability of at least, so students, probability of at least one success is at least 1 by 4. So P of X greater than or equal to 1. P of X is equal to 1 means what, students? Probability of getting exactly one success. You already know that P of X is equal to R in binomial distribution. NCR into Q power N minus R into P power R. So P of probability to get R successes is NCR into Q power N minus R into P power R. You already know that. So probability of at least one success is at least 1 by 4. So that's it, students. So how to get this? Actually, its expansion is P of X is equal to 1 plus P of X is equal to 2 and so on. Binomial distribution ends at N. Okay. So P of X is equal to N is greater than or equal to 1 by 4. So better to write this in complement manner. So 1 minus of P of X is equal to 0 is greater than or equal to 1 by 4 students. So it is 1 minus P of x is equal to 0 means what, students? NC naught into Q par n into P par 0 is greater than or equal to 1 by 4. Then you will be left with 1 minus NC naught, that is 1 students. So here Q value how much? 9 upon 10. 9 upon 10 whole power n P par 0 1 is greater than or equal to 1 by 4 students. Then just multiplying by minus on both sides, you will be left with 9 by 10 whole power n minus 1 less than or equal to minus 1 by 4. Then it is 9 by 10 whole power n is less than or equal to 3 by 4 students. How easy it is, isn't it? Or 10 by 9, carefully watch. 10 by 9 whole power n is greater than or equal to 4 by 3. By observing, you see students, n values. 1, if you put n value 1 student, 9 by 10 whole power, that is 0.9 less than or equal to 3 by 4, ruled out. So here 1 is failed, and next 2 is also not correct there, students. Next 3, 9 by 10 whole cube. So carefully watch, students, which is less than 0.75, something 0.6 something will come. So by observation, n is equal to 3, 4, 5, etc. are correct. Therefore, minimum value of n, therefore, minimum value of n is 3 students. See this, students, just it is a simple problem based on binomial distribution of probability chapter. So here hitting the target is a success, and accordingly we can do the problem, students. Carefully note down. Students, next problem. If a plus root 2 into b cos x into a minus root 2 into b cos y is equal to a square minus b square, then the value of dx by dy at pi by 4 comma pi by 4. This is the problem, students. So how to crack this problem? Carefully watch, students. Okay, as usual, what I am going to do is I just differentiate in UV form. Okay, so first a plus root 2 into b cos x I write as it is. This one I write as I differentiate the second function. It will be a derivative of constant 0. It is minus root 2b cos y derivative, students, minus sin y into dy by dx. Okay. Afterwards, plus a minus root 2b into cos y I write as it is, students. I differentiate the first bracket. If you differentiate that, you will be left with minus root 2 of b into sin x is equal to RHS 0, students. So put, as the location is pi by 4 comma pi by 4, abscissa is pi by 4 and ordinate is also pi by 4. So what I am going to do is put x is equal to y is equal to pi by 4, students. Then you will be left with a plus root 2b into cos pi by 4 1 by root 2 into, what is this, students? Carefully you observe, it is minus into minus plus root 2 into b sin pi by 4, again 1 by root 2 dy by dx plus a minus root 2b into 1 by root 2, students, into minus root 2b into 1 by root 2 is equal to 0. Then it leads to this root 2 part will be cancelled in all brackets like this. Then what you have, students? A plus b into here b into dy by dx plus a minus b into minus b is equal to 0. Therefore, a plus b into dy by dx is equal to b of a minus b. That implies dy by dx is equal to b of a minus b upon b of a plus b. But your question is dx by dy at pi by 4 comma pi by 4. Already I kept x is equal to pi by 4 and y is equal to pi by 4. So answer will be a plus b upon a minus b, students. Just a problem based on UV formula and direct differentiation. This is a dx by dy asked, students. So you have to do it carefully. Next problem, students, you have to observe carefully. Students, next problem. If f of x plus y is equal to f of x plus f of y plus xy square plus x square y, and the limit extends to 0, f of x by x is equal to 1, then what is the value of f dash 3? So how to handle this problem? Students, by the definition of derivative, limit extends to a, f of x minus f of a upon x minus a. If this exists finitely, then it is denoted by f dash a. So you are clearly given limit extends to 0, f of x, I write minus f of 0 by x minus 0. That is 1, which is nothing but f dash 0. Why? Because if you put x0 and y0 here, so f dash 0 is going to be 1. So f dash 0 is equal to 1. This is result number 1. Next, differentiating given equation partially with respect to x, students. Differentiating given equation partially with respect to x. That is treating y as a constant, students. So shall we differentiate that particular equation? Start. F of x plus y derivative f dash x plus y into x plus y chain rule. We are differentiating partially with respect to x, means x is variable for us now. Y is constant. So just x plus y derivative 1. Leave it. On the right side, f of x derivative f dash x, f of y becomes 0. Leave it. Plus x y square. Y square is a constant for you. X is variable. So x derivative 1 into y square plus here x square derivative 2x y constant as it is, you write. So plus 2xy, students. So what do you have here? F dash x plus y is equal to f dash x plus y square plus 2xy. Your goal is f dash 3, students. Already you know f dash 0. Okay. So our answer came, put x is equal to 0 and y is equal to 3. Therefore, you have f dash 3 is equal to, students, f dash 0 plus y square 9 plus this is 0, right? Implies f dash 3 is equal to, students, f dash 0 value 1 plus 9. So answer is 10. So simply the problem is constructed. So limit extends to a, f of x minus f of a by x minus a. If that particular limit exists finitely, then it is denoted by f dash a, which is nothing but derivative of f of x at x is equal to a, students. So after that, I have, this is functional equation. Without doing partial differentiation also, by putting y is equal to minus x there, we can handle the problem. So functional equations can be handled in various ways. Okay, students. So another easy and logical problem, students. Carefully note. Next problem, students, carefully observe. If f is twice a differentiable function for all x belongs to R, students, for all x belongs to R, such that f of 2 is equal to 5, f dash 2 is equal to 8, and f dash x is greater than or equal to 1, f double dash x is greater than or equal to 4, then we have to recognize the correct option based on this data. So students, carefully observe how to crack this problem. First of all, f dash x is greater than or equal to 1. Now let us integrate on both sides between the limits 2 and 5 because the data is available there. Okay, students. So I am going to integrate like that. So what is happening there? Carefully you observe. Integral 2 to 5 f dash x dx is greater than or equal to integral 2 to 5 1 dx. Okay, students, then it will be integral f dash x. So you will be left with f of x under the influence of the limits 2 to 5 is greater than or equal to just x 2 to 5. So it will be f of 5 minus f of 2 students greater than or equal to 3 students. In the data it is given f of 2 is equal to 5. See here, f of 2 is equal to 5. Then you will be left with f of 5 is greater than or equal to f of 2 already 5, 5 plus 3, 8. So this is equation number 1, students. Next, also given that f double dash x is greater than or equal to 4. F double dash x is greater than or equal to 4. Again, same what I am going to do is integral, same 2 to 5, f double dash x dx is greater than or equal to integral 2 to 5, 4 dx. Then it will be, students, just f dash x 2 to 5 is greater than or equal to, this is 12 students. Then you will be left with f dash 5 minus f dash 2 is greater than or equal to 12. Implies in the data f dash 2 is given as 8 students. So f dash 5 is greater than or equal to 20. Equation number 2. Now 1 plus 2 implies f of 5 plus f dash 5 is greater than or equal to 28 students. F of 5 plus f dash 5 is greater than or equal to 28. So simply just by seeing the data f of 2 is equal to 5 and f dash 2 is equal to 8, and by taking these two inequalities one after one, we can get the, and by taking suitable limits on both sides, by integrating that, we can get the result, students. Carefully watch it. Students, next problem. If 2x square plus 3x plus 4 whole power 10 is equal to sigma AR into x power r, where r runs from 0 to 20, then A7 upon A30. Students, this problem is basically multinomial expansion related problem. Already I told you earlier also multinomial expansion, how to crack this. First of all, general term of this expansion is going to be, students, 2x square power some alpha I take, students, 3x power some beta I take, students, 4 power gamma, right? Its coefficient is going to be 10 factorial upon factorial alpha into factorial beta into gamma factorial. Under the conditions, there are some restrictions where alpha, beta, gamma each can take its value from 0 to 10, any number, and alpha plus beta plus gamma is equal to 10. This is how to write the general term of any multinomial expansion. If you take sigma here, it is giving the entire series. Now, A7 means coefficient of x power 7. Similarly, A13 means coefficient of x power 13. Right? Now, see, observe these powers alpha, beta, gamma. Two restrictions are there. Alpha plus beta plus gamma should be 10, which is the power of the given multinomial. At the same time, alpha, beta, gamma can take any number from 0 to 10, any integer. It is similar to distributing n similar things among r persons, where each person can take any number of things. That concept actually, which is connected to permutations and combinations concept. That is why binomial theorem and permutations and combinations chapters are correlated. Now, I prepare some tabular form, students. First of all, regarding A7, I am going to prepare some tabular form. So carefully you observe. Watch, students. Alpha, beta, gamma. Regarding that, first of all, I want to take alpha as 3 students and beta as 1. Obviously, gamma is going to be 6 because 3 plus 1 plus 6 is 10. Now, alpha 3 means, watch here. Alpha 3 means this is x square, 2x square whole cube, x power 6. First of all, you concentrate on the x term only. X power 6. Beta 1 means what? Here x power 1 is coming. So, x power 7. Your task is also x power 7. This is one case. Now, let us try in various ways. Okay. What are the various ways to get coefficient of x power 7? Let us have a look, students. Now, I take alpha as 2 students. Beta 3, 1 minute. Alpha 2 means x power 4 will come. Beta 3 means x cube. X power 4 into x cube. X power 7 will come. So obviously here remaining the power to be accommodated there in the place of gamma. Okay, nice. Now I want to take alpha as 1 students. Next beta as 5. Remaining 4. Why? Because students, alpha 1 means here x square came, beta 5 means x power 5 came, gamma 4. Okay, nice. Is there any other way, students? Is there any other way? Any other way? Yes. If you take beta as 7 and gamma as 3, alpha 0. Don't entertain any number here other than 0 here. Why? Because already beta 7 means x power 7 came. I think these ways are favorable here. Okay. Now, when you give these numbers here, answer is coming. A7, that is coefficient of x power 7 is equal to, first 316 students. So 10 factorial by 3 factorial into 1 factorial into 6 factorial. If you keep 3 here, the coefficient is 2 cube into 3 power 1 into just 4 power 6. Are you getting well? 316. Accommodate 316 in the places of alpha, beta, gamma, students. It is 2 cube, 3 power 1, 4 power 6 over. Next, plus. Second row. What is this? 10 factorial by 2 factorial into 3 factorial into 5 factorial into, when alpha is 2, it is 2 square coming. Beta 3 means 3 cube. Gamma 5 means 4 power 5. 4 power 5. Next, plus. Third row. 10 factorial upon 1 factorial into 5 factorial into 4 factorial. Alpha 1 means 2 power 1 into beta 5 means, what is there, students? It is 3 power 5. Am I not right? 3 power 5 Next, gamma 4 means 4 power 4. So what is coming? 2 power 1 into 3 power 5 into 4 power 4. Still there, wait, fourth row. 10 factorial by 0 factorial, 7 factorial, 3 factorial. 0 factorial. So alpha 0 means first term ignore, leave it. Beta 7 means it is 3 power 7 students. And gamma 3 means 4 cube. So this is A7. Similarly, wait a moment. A13, that is coefficient of x power 13. Previous tabular form is not favorable for my job right now because it was given keeping x power 7 in the mind. Now what I am going to do is alpha, beta, gamma. Same how it comes. Let me have a look. Keep this general term with you students. Again, I am writing general term for my comfort. General term is n factorial by alpha factorial, beta factorial, gamma factorial into 2x square whole power alpha, 3x whole power beta, 4 power gamma. Isn't it? See, 3x square whole power alpha, 3x whole power beta, 4 power gamma. Okay, nice. Now students, be active. Now my task is x power 13. See here. See here and get. I want to put alpha as 6 students. If you put alpha 6, x square whole power 6, x power 12 came. Here 3x is there. So I keep beta as 1. But as I told you earlier, alpha plus beta plus gamma should be 10. That is mandatory. So obviously you are forced to keep 3 here. This is one possibility. Am I not right? Now next alpha I take 5, beta 3, gamma 2. If you take alpha as 5, x power 10, beta 3 means x cube, 10 plus 3, 13, that is gain. Okay, nice. Next, alpha 4 I want to take students, then x power 8 is coming. Beta 5 I will take, and gamma obviously 1 I have to take, right? Then what is coming there? Alpha 3 I take students. If you take alpha 3, then what is coming? 4 power 0, 7. Wonderful, 7, 0. If you take alpha as 3 students, x power 6, I take beta as 7. So x power 7, so x power 13 coming. So obviously gamma is 0, right? Therefore, A13 is going to be, keep this data, 10 factorial upon 6 factorial into 1 factorial into 3 factorial. If alpha is 6, it is 2 power 6, beta 1, 3 power 1, 4 cube. Okay, next, plus next term, 10 factorial upon 5 factorial, 3 factorial, 2 factorial. Into 5, 3, 2 means what comes students? 2 power 5, next 3 cube, next 4 square. 2 power 5, 3 cube into 4 square. Okay. Next, plus next term what students? 10 factorial by 4 factorial into 5 factorial into 1 factorial into 2 power 4 into 3 power 5 into 4 power 1 last, plus 10 factorial upon 3 factorial, 7 factorial, 0 factorial. 0 factorial 1, no problem. Into 3 means what comes? 2 cube into 3 power what students? 7 into 4 power 0. So your task is what? See the problem students. Your task is A7 by A13. Your task is A7 by. So students, finally, your task is A7 upon A13. A7 upon A13. On simplification, you will be left with 2 cube students. That is nothing but 8. So the answer is 8 students. Next problem students. If from the point 3 comma 3 on the hyperbola x square by a square minus y square by b square is equal to 1, a normal is drawn which cuts the x-axis at 9 comma 0, then the value of a square comma e square. So by following usual notation, e stands for the eccentricity, students. So this is the problem. So how to handle this problem? Carefully watch. First of all, the point P 3 comma 3 lies on the hyperbola. So as it lies on the hyperbola, we can keep the point there in the place of x comma y. Then you have 9 upon a square minus 9 upon b square is equal to 1, right? So 9 of 1 upon a square minus 1 upon b square is equal to 1. Therefore, you have 1 upon a square minus 1 upon b square is equal to 1 upon 9. Equation number 1, students. Now, what is happening there? From this so-called point 3 comma 3, we are drawing a normal, okay, which cuts the x-axis. So just a rough sketch will be like this. So from that point, so-called point 3 comma 3, we are drawing a normal like this. It is a transverse axis, so which cuts the x-axis at 9 comma 0. Okay, right. Next line. In hyperbola chapter, equation of normal at x1 comma y1 means point form of the normal is what, students? A square x upon x1 plus b square y upon y1 is equal to a square plus b square. This is the point form of the normal. Here normal is drawn at 3 comma 3 means x1 comma y1 is 3 comma 3. So I am going to substitute there. So a square x upon 3 plus b square y upon 3 is equal to a square plus b square. This so-called normal is passing through 9 comma 0, students. See here. This normal is passing through 9 comma 0 there. So put 9 comma 0. So if you put 9 comma 0 there, students, you will be left with what? 9a square upon 3 plus 0 is equal to a square plus b square. That is 3a square is equal to a square plus b square, students. Implies 2a square is equal to b square. 2a square is equal to b square. You are asked a square comma e square. Okay. 2a square is equal to b square is a useful result, in fact. Now 1 implies, what is 1, students? 1 upon a square minus 1 upon b square can be written as 2a square, students. B square is 2a square is equal to 1 upon 9. Therefore, on calculation, you are having 2a square is equal to 9 implies a square value 9 upon 2. A square value 9 upon 2 means from 2, you have b square is equal to 2 of 9 upon 2, that is equal to 9. Last step. In hyperbola, it is hyperbola, students. In hyperbola, eccentricity formula, e is equal to root over a square plus b square upon a square. Your task is e square. E square will be 1 plus b square upon a square, which is nothing but 1 plus b square value, what, students? 9 upon a square value 9 by 2. So e square is going to be finally how much, students? 3. So your task is a square comma e square. A square is 9 upon 2, e square is 3. So 9 upon 2 comma 3 is the answer. So answer is the first option, students. Carefully you have to note down. Students, next problem. This is mathematical reasoning problem. Logic. Consider two statements. Statement 1, negation of p implies negation of q implies and is implied by negation of p is a tautology. Statement 2, negation of q and p implies q is a fallacy. Fallacy means a contradiction. Okay, already, students, you know that a statement is said to be tautology if all are T's there in its truth table in the last column, and a statement is said to be contradiction or fallacy if all are F's in the last column of the truth table of that particular compound statement. Okay, students. Now options S1 is true, S2 is false, S1 is false, S2 is true. Both are true and both are false. Now just it is a simple problem, but we have to prepare one tabular form, students. Now carefully you watch. Now let us prepare the tabular form, how it comes. As you know that when you have two statements TT, TF, FT, FF, because each statement has two possibilities regarding truth values, either T or F. So each statement has two possibilities. Two statements means 2 into 2. So 4 possibilities are there. Now negation of T column I write. Means this third column I am going to write just negation of the first column. So what comes, students? F, F, T, T. This is what about the third column, students. Now negation of Q I am going to write, students. Negation of Q means what? Just the negation of the second column. So keep second column. Keep an eye on this second column. Okay, now it will be F, T, F, T. So what comes? F, T, F, T. Now third column, whatever I want, only those compound statements only I have written here, students. Okay. Actually, my question is statement 1 is this one. This is statement 1, students, and this is statement 2. Yes or no? Okay. Now to discuss this, let me find this negation of Q implies and is implied by negation of P. So students, negation of Q means between third column and fourth column. So third column versus fourth column by implication. What, students? By implication, by conditional. You know, by conditional compound statements will be true only when both have the same truth value. So F, same truth value means what comes, students? This is true. Here FT, different truth values are there. Here also different truth values are there. In case of by implication, okay, or by conditional, okay, then what is happening there? Here it is F. Again, here same truth value is there, TT available there. So it is again coming as T, students. Now our statement 1, this is statement 1 only. This is statement 2. They gave in the problem, this is tautology. If really it is tautology, here all truth values should be T only. Now what versus what? Negation of P means third column versus fifth column. Third column versus fifth column. What? Just implication. Only here implies symbol is there. Implication or conditional. F implies T. Students, F implies T. Is T. Already you studied that in implication table. F implies F is also T. Next, T implies F. T implies F means F, students. And T implies T is also T. So here, why it is not tautology? Because all are T's except this. So S1 is not tautology. Right, next. So what they told, S1 is false. That is, S1 is false. S1 is false, students. S1 is false. Now, negation of Q and P. Negation of Q and P means, let me tell. Right. Negation of Q and P means, see here. First column versus fourth column, students. Negation of Q and P. T and F is F. Next, T and T is T. F and F is F. Next, F and T is again F. Now last, see, students, negation of Q and P implies Q. So this column, carefully watch, students, I mark here. This implies Q. This, shall we read? Come on, right. F implies T. Students, last, negation of Q and P implies Q. So this column and this column you observe. F implies T. F implies T is T. Next, T implies F is F. Next, F implies T. Again same T. F implies F is T. Students, they gave this as fallacy. Look, contradiction. Is it contradiction? No. Clearly, S2 is also false. So, what is the correct answer? Both are false, students. Both are false. So, you have to prepare the tabular form carefully, students. Accordingly, you have to observe. So, in this tabular form, we used implication as well as by implication. Okay. So, both we have used, students. Okay, students. Next problem. If A is equal to matrix cos theta, I sin theta, cos theta, and A power 5 is equal to matrix A, D, B, C given, where theta lies between 0 and pi by 24 given, students, then which of the following is false? Question is, which of the following is false, students? Okay. First of all, let us find A square. A square will be matrix cos theta, I sin theta, cos theta, right, into again cos theta, I sin theta, cos theta. You know already, two matrices can be multiplied using row by column operation. So it will be what, students? Cos square theta plus I square sin square theta. It will be cos theta into I sin theta plus cos theta into I sin theta. Next, second row, students. I sin theta cos theta plus I sin theta cos theta. Next one, cos I square sin square theta, I square sin square theta plus cos square theta. This is coming like this, students. So what you have? Okay, students. So I sin theta cos theta plus I sin theta cos theta. Similarly here, what is coming there? I square sin square theta plus cos square theta. Then it will be what, students? Cos square theta, I square value minus 1 minus sin square theta. That is going to be cos 2 theta. This is I sin theta cos theta plus I sin theta cos theta. So what is coming, students? 2I sin theta cos means I sin 2 theta. This is again same, I sin 2 theta. This one cos square theta minus sin square theta cos 2 theta. Therefore, I got A square value like this, students. Continuing the same trend, A cube will be cos 3 theta, I sin 3 theta, cos 3 theta will come. Similarly, your question is what? A power 5, students. Okay. Therefore, A power 5 is coming as cos of 5 theta, I sin of 5 theta, cos of 5 theta. This is given as ADBC, students. This is given as, carefully you have to observe, this is given as ABCD. This is given as what, students? ABCD. Carefully you have to observe. This is given as ABCD. In the problem, it is ABCD. Okay, nice. Equate. If you equate like that, you will be having A, B, C, D. So as A power 5 value is equated like that, what I am going to have, corresponding components I will equate. Therefore, A value cos of 5 theta, B value I sine of 5 theta, C value I sine of 5 theta, next D value cos of 5 theta. Now the question is, which of the following is false? First option, A square minus B square value. Option 1, A square minus B square. A square means cos square 5 theta minus B square means minus I square sine square 5 theta. So you have one students, but they gave A square minus B square is equal to 1 by 2. So first option is undoubtedly false. So remaining three options definitely will be correct. Next, A square plus B square students. Second option, if you observe, A square plus B square will be cos square 5 theta, I think plus I square means here minus sine square 5 theta will come. It is nothing but cos 2 of 5 theta, cos 10 theta. Clearly given that theta belongs to which quadrant, which interval students, 0 to pi by 24. 0 to pi by 24. Then 10 theta, okay, belongs to what students? Carefully if you observe, it is going to be 10 theta interval. You watch this. Theta belongs to 0 to 24 means cos of 10 theta is undoubtedly positive value will come, students. Just you have to observe that belongs to 0 to 1 only because theta is in this particular interval. Next, option 3, A square minus D square, students. Third option is A square minus D square. A square minus D square means cos square 5 theta minus D square, again cos square 5 theta is 0. It is also correct, students. Fourth option, what is fourth option, students? A square minus C square. A square minus C square, that is cos square 5 theta minus C square means minus I square means plus sine square 5 theta will come. That is also 1. They gave that also as 1. So as per the question, which of the following is false means we have to opt option 1, students. See how this problem is given. Just you are given theta belongs to 0 to pi by 24 means here this so-called 10 theta angle is also giving cos of 10 theta is giving a positive value undoubtedly. Okay, students, right?
Hello everyone. We are going to discuss IIT JEE Mains September 4th Shift 1 paper. So let us begin with question number 1. Question 1 says that in a group, 63% of the people read newspaper A. So and 76% people read newspaper B. So let us say the people who are going to read newspaper A are 63. We can take 63%, but we will take 63 so that the total set, we will say universal set contains 100 elements. And these are 63 of them. Similarly, those who read newspaper B are 76 in number. And the question is asking us the number of people who read both A and B. And that is given to us as X. And we are asked what is X, what kind of percentage X may have. So we will use the formula n of A union B is nothing but n of A plus n of B minus n of A intersection B. But we know that n of A union B is at most equal to the universal set. So this number will be less than equal to 100 in all cases. So what we have is 100 is less than equal to n of A is 63 plus n of B is 76, n of A intersection B is X. So we get this. So this is going to imply that X is more than equal to 39. Also, one can observe that n of A intersection B is going to be less than or at the most equal to n of A. So this gives us an upper estimate on X. So this, therefore, I get X is less than equal to n of A, which is 63. So clubbing these two together, I see that X is in between 39 and 63. We took a number, but actually the question is about percentage. So we will have a number which is in between them. So option 4 is a number which is in between them. So option 4 is the answer for this question. Let us move on to the next question. The next question is asking us the value of this integral at 3 minus the value of the integral at 1. So let us simplify this integral itself. So here the function is f(x) is given to us as root x, integral of root x by 1 plus x square whole square dx. So let us substitute x as tan square theta. So dx is going to be derivative of tan square theta is 2 tan theta into derivative of tan theta, that is secant square theta d theta. So we will substitute this in this. So we will see that this becomes the integral of tan theta by, we have 1 plus x. 1 plus x is 1 plus tan square theta. So 1 plus tan square theta is secant square theta whole square into dx. Dx we have just written as 2 tan theta secant square theta d theta. So if we see, this simplifies to the integral 2 tan square theta, and the secant square, one secant square will cancel. That we can rewrite as cos square theta d theta. So this integral is nothing but integral of 2 times of sin square theta d theta. But sin square theta can be written in terms of cos theta. So this will be nothing but 1 minus cos 2 theta d theta. So this is the integral values so far. But now we know what is the integral of 1 minus cos 2 theta, because it is integral of theta minus integral of cos 2 theta, of course with d theta over here and d theta over here. So integral of theta d theta is nothing but integral of so this is 1 theta. So integral of 1 theta is nothing but theta minus integral of cos 2 theta is sin 2 theta by 2 plus a constant. So this is what is the integral. But this integral is in terms of sin theta. We can convert it in terms of tan theta. So this is nothing but theta minus sin 2 theta is nothing but tan 2 tan theta by 1 minus 1 plus tan square theta into 2 is also there, into 1 by 2 plus this c. So we see that in this case the function f(x) is nothing but theta, which is tan inverse x, tan inverse of root x minus 2 tan theta. The 2 is cancelled, so tan theta, which is root x by 1 plus x plus a constant. So therefore f of 3 minus f of 1, the constant will disappear, and we will see that this expression is nothing but tan inverse of root 3 minus root 3 by 1 plus 3, that is 4, minus tan inverse of root 1 minus of minus 1 by 2. So this expression simplifies to pi by 12 plus 1 by 2 minus root 3 by 4. That is precisely option number 2. Hence our answer is 2 in this case. Let's move on to the next question. The next question here is asking about a right angle triangle ABC, right angled at A. So let us draw a figure. So this is a right angle triangle, right angled at A, and A's coordinates are given to us as 1, 2. C coordinate is given to us as 3, 1, and B's coordinate we do not know, but we want the abscissa of the B coordinate. So let us take alpha and beta as the coordinates of B, and we are interested in the abscissa of B. Now what do we know? We know this area is pi root 5. So we know the area of the triangle ABC is pi root 5. Okay. So this is one thing that we have. But what is area? Area is half into base into height. Half into base. The base I can take it as AC, or AB is the base, into the height is AC. This is given to me as 5 root 5. Now that means I just have AB into AC is nothing but 10 root 5. But AB I know because I know in terms of alpha and beta I will know AB. So AB is nothing but alpha minus 1 whole square plus beta minus 2 whole square. Root of this is AB. Similarly, AC is nothing but 3 minus 1 whole square plus root of 1 minus 2 whole square. This is 10 root 5. So this is one information that I have. If I simplify this, I see that I will not be able to get rid of beta here, so or alpha here. I will have that in it. So I need one more information. Now, is there any other information available? The information available to us is that this is a right angle triangle. That means I know that slope of AC into slope of AB, or is the product of these slopes is minus 1. But what is slope of AB? Slope of AB is nothing but beta minus 2 by alpha minus 1. And what is slope of AC? Slope of AC is 2 minus 1 by 1 minus 3. So this product is minus 1. So here I get a relation between alpha and beta. So this implies that beta is nothing but twice of alpha. Now I can substitute this beta into this expression. I substitute the beta in this expression, I'll get alpha expression. So if I substitute beta in this, what I have is alpha minus 1 square plus I'm going to have 2 alpha minus 2 whole square under root into this quantity. 1/2 is also there. We have taken care of that 1/2. Into this, that is 3 minus 1 square, that is 4 plus 1 root 5 is equal to 10 root 5. So you can see this root 5s will cancel off and we will get this expression equals this. So from here, we can see that alpha is having this, will get alpha minus 1 actually mod, because we'll have a root square. So that root square will cancel and we'll get this as 2 root 5. So we see that there are two possible values of alpha. So this implies alpha is 1 plus or minus 2 root 5. But here we have only been given one value. So we can say that the abscissa of B is nothing but option 2. So this is the answer for the third question that we have seen. Coming on to the fourth question, we have fx given to us as mod x minus 2 and we want to find what is g of f of fx. G of x is given to us as f of fx. So let me drop this off. So g of x here is given to me as f of fx. So we want to find what is gx. So we need f of fx. But clearly fx is defined to me as x minus 2, mod x minus 2. So what is fx? So fx is nothing but, I know that is going to be same as negative of this if I take x less than 2, and it is going to be x minus 2, same as if x is greater than 2. We can put equality anywhere, so let us put the equality here. So what is f of fx? So f of fx again makes sense as 2 minus fx whenever fx is less than 2, but we are doing this in the case when x is less than 2, and similarly it is same as fx minus 2 whenever fx is greater than equal to. So now we have to substitute the value of fx. But what is fx? Fx takes two values. So I can substitute fx as 2 minus x. I'm substituting fx, this fx can be substituted as 2 minus x depending on whether I take x less than 2 or greater than 2. So this is for x less than 2. So I will substitute this whenever x is less than 2. but I also have the restriction that fx is less than 2. So this is also fx is less than 2. So I have to have both this as well as this in this case. Similarly, I will write down it as 2 minus fx, but in that case, fx can be taken as x minus 2, or I can write in these cases. So there are total 4 cases. So if we write down all the cases, I can see that this can be written as 2 minus x minus 2. Whenever fx, this is 2 minus x, which is greater than or equal to 2, or this x is less than 2. Similarly, in this case, we will have it as 2 minus x minus 2 whenever I take x minus 2 less than 2 and x greater than or equal to 2. Or again, I take the case when x is greater than 2. So in the case where x is greater than 2, I will write it as x minus 2 minus 2. Again, this is the case where x minus 2 is greater than or equal to 2. So I have these 4 cases in which I have the function fx. So let us simplify this fx. So we get f of fx. So this is what we get our gx upon simplification. Upon simplification, we see that gx is just x whenever x is in between 0 and 2. That's the first case, because I want x to be less than 2 and I want fx to be less than 2. That means I want, this is same as saying that 2 minus x is less than 2. So you can see that I want x to be greater than 0, and I want, so this case itself is saying 2 things. I want x to be greater than 0 also, and I want x to be less than 2 also. So that's the case when x is in between 0 and 2. So in this case, you can see that 2 minus x, 2 minus x will cancel out and I'll get x. Similarly, the next case, I see it is just minus x, but this is the case when 2 minus x is greater than or equal to 2 and x is less than or equal to 2. So that is same as x is less than or equal to 0. Similarly, if you write down the other 2 cases, you will get x in between this for 2 and 4, and this case for x minus 4 for x greater than or equal to 2. So that is our gx. Now we are asked the integral of 0 to 3 g of x minus fx. Now you can see that the integral is changing, the g is changing values at 2 and 0 and 4, but we are only interested in 0 to 3, so we will split the integral at 2. So this can be splitted at 0 to 2. So 0 to 2, what is the value of gx? 0 to 2, the value of gx is x only, plus I can split it at 2 to 3, I mean the same part, but in 2 to 3 I will be taking it as 4 minus x. This is nothing but gx written. Now minus fx I have. Fx is again given to me from 0 to 3 only. Again I have to take fx, that is x minus 2. Again that splitting is there. All this is with dx, with dx. This is also with dx. So we can simplify this, this integral from 0 to 2x dx. We can actually solve it. If you solve these all values, you will get the answer as 1. Okay, so moving on to the next question. So I've been asked summation of 50 minus r c6. Now you can see this r is varying from 0 to 20. So typically what are the terms that are asked? I will substitute for some values of r. So r is 0, I am asked 50 c6. Plus r is 1 means I am going to look at 49 c6. And I keep on doing this. Ultimately, when r becomes 20, I will be at 30 c6. So this sum is asked to me. Now what we will do is, this is 30 c6. So I don't have a term. I mean, the base here is always 6. So what I will do is I will add to this 30 c7 and subtract 30 c7. Doing this, what happens is I can club these two together. It's like 30 c6, 30 c7. 30 c6 and 30 c7 I know is nothing but 31 c7. So this is just going to give me 31 C7. But you see the prior term to this was 31C6. So now I have a 31C6 to work with these two. Okay. I have a 31C6. Now using the same logic, these two terms will add up to 32C7. But now term prior to this was 31C7. Sorry, 32C6. So here also I have a 32C6. So here also I have a 32C6. So you can see that the trend is continuing and it will continue up to this 50C6. Isn't it? So this term I'll keep as it is 50C6, but keep on doing all these terms. So I'm going to get ultimately 50C7. 50C7 and this minus this 30C7 as it is, because this minus 30C7 I keep this as it is, minus 30C7 as it is. If I just complete all the terms, so this is what I have eventually. If I look at it, this is what it looks like. But then this again is nothing but 51C7 minus this 30C7 as it is. So it comes out as option number 3 in this case. All right. Okay. So let us look at the next question. It's a differential equation. So clearly this x part is involved in the differential equation. So I want to get rid of this x part. I'll divide by x. So I see that this expression is dy by dx minus y by x is equal to x times, I'm going to have x cos x plus sin. Right? So what is the integrating factor? Because this expression looks like dy by dx plus minus 1 by x times y is equal to some function of x, some q of x. So this is like a linear differential equation. So we know that the integrating factor for this linear differential equation is e to the power integral of p of x dx, that is minus 1 by x dx. So what is this integrating factor? So it is e to the power integral of minus ln x, which is just 1 by x. So we see that the integrating factor is 1 by x. So our solution is y into integrating factor is equal to q of x into integrating factor, integral. So x into cos x plus sin x. Why? Because this x and this integrating factor x cancels off this dx. But integral of x cos x plus sin x is nothing but the integral of x sin x only, because it's the derivative of x sin x. So this is just x sin x plus a constant. So what we have got y as, so y comes out as x square sin x plus c times x. But what is the constant? What is given to us is that we have this expression. We can see that it is given to us as that f of pi is pi. So pi is equal to f of pi. The moment I substitute pi, I find pi, which is 0. I got the expression y in this case as x square sin x plus x itself. Now what is asked to me is the derivative of this plus at pi by 2 and the derivative double derivative of it at pi by 2. So I'll differentiate this. So I want the derivative of this. So what is dy by dx? So dy by dx here is x square into derivative of sin x is cos x plus 2x derivative of x square into sin x as it is plus 1. This is the derivative. And we also want the second derivative, that is d square y by dx square. So that is going to be x square into derivative of cos x is minus sin x plus cos x into derivative of x square is 2x plus derivative of 2x sin x. That means I'm going to have x into derivative of sin x So that is x into x plus 2 sin x into derivative of x. 1. So this is it that we have. So value f double prime at pi by 2. Cos is going to vanish. So the one which is going to remain is the sine expression. And then so you can see that this expression is just pi square minus pi square by 4 plus 2. And this expression is going to be pi square by 4 plus pi by 2. If we add these two up, this part cancels off, and I'll see it comes out as pi by 2 plus 2. So that is our answer. In this case, that is option 1. Okay, moving on to the next question. So what is given here is it's an ellipse with lattice rectum 10. We know the length of the lattice rectum is nothing but 2b square by a. So this is given to us as 10. So we know that this implies basically b square is nothing but 5a. Also, it is said that the eccentricity is equal to the max value of this quadratic expression. So we want to find max of this f of t, which is 5 by 12 plus t minus t square. We can complete the squares of this expression and rewrite this as 2 by 3 minus t minus half whole square. So we can see the max of f max is nothing but 2 by 3 only, which is given to us as the eccentricity of the ellipse. So we have E here, and we want a square plus b square, but we also know b square in another way as a square into 1 minus e square. So we have it as a square into 1 minus e square, which is 4 by 9. But b square we have already said is 5a. So this gives us the value of a itself. So this implies a is just 9. Therefore a square is 81. But once we have a square, we have b. B square is 5 into that expression 9, that is 45. So b square is 45. So we have a square and we have b square. So a square plus b square is 81 plus 45, which turns out to be 126. Okay, moving on to the next question. It said that alpha and beta are roots of this expression. So what we know is sum of the roots and the product of the roots. So sum of the roots is known to us as alpha plus beta is 3. And we also know the product of the roots, that is b. Similarly, gamma delta are the roots of this. So sum of the roots is known to us as 6, and the product of the roots is known to us as q. Now what is said further that alpha, beta, gamma, delta are in increasing GP. If they are in increasing GP, I can take alpha itself as a, beta as AR, gamma as AR square, and delta as AR cube, because they form a GP. Okay, so I have alpha plus beta, I have gamma plus delta. So these two values I know actually. So I know alpha plus beta is actually gamma plus delta by 2. And alpha plus beta, so this in this I can substitute the values of alpha and beta. So a plus AR is same as AR square plus AR cube by 2. So I can cancel out A because A is not 0. Why? Because A is an increasing GP. So if I cancel out A, I see 1 plus R is equal to, I can again remove R square out from here, 1 plus R by 2. So this is going to imply that R square is nothing but 2, because 1 plus R will cancel out, otherwise R will be equal to minus 1, which is not possible. So R square is 2. So once I have R square as 2, all I have to do is substitute the value of R square in the expression for 2q plus p by 2q minus 1. But what is 2q? 2q is nothing but 2 times gamma delta plus p. P I know is alpha beta by same expression. I am going to have 2 times gamma delta minus alpha beta. And I already know what is gamma, what is delta, because I know the value of r square. So I'll substitute these values in it. So gamma expression is nothing but ar square. So let us put it as 2 times of a r square. Maybe let us write in r first of all. Into I'm going to have a r cube plus I'm going to have alpha beta. Alpha beta is nothing but a into ar. Similarly, the expression I'm going to have is 2a r square into ar cube minus a into ar. So you can see that all the a's, we get rid of all the a's, and we see that this is just 2r to the power 5 plus r by 2r to the power 5 minus r. And we already know the value of r is nothing but root 2. So we can substitute the value, it's plus or minus root 2, but we can substitute in here. We see that this r will also cancel out. So we'll see that this is just 2r fourth plus 1 by 2r fourth minus 1. We don't need r's. We can write r fourth directly is 4. So it is 2 times 4, that is 8 plus 1, 9 by 8 minus 1, that is 7. That is 9 by 7, that is option 3, as we have already seen. Okay, so let us move on to the next question. The mean and the variance are given. So this is a simple question. Mean means the average of all these. So the average of all these numbers is given to us as 10. That means 5 plus 7 plus so on, and 14 plus a plus b. Average. These numbers are 8 in number. So this by 8 is given to us as 10. So this gives me that a plus b value. I can see that a plus b comes out as 17 here. Also, its variance is given. Variance we know is nothing but variance. The formula for variance is nothing but summation of xi squares by n minus mean square. So if we substitute in the values, so this is going to imply the variance, that is 13.5, is equal to all these squares minus the mean. So squares of individual numbers are 25 plus 49 plus 144 plus 100 plus 225 plus 196 plus a square plus b square. These by n is 8 only, minus the mean which we have already been given as 10. So 10 square, that is minus 100. So if you see this expression again involves an a square plus b square. This simplifies to a square plus b square as 169. Now we have two expressions in a and b, and we want the value of a minus b. We want a minus b. But if a square plus b square is given, means I know what is a plus b whole square. This is same as a square plus b square minus 2ab. This is 169. So I know what is a plus b whole square. So a plus b whole square from here can be said as 169 plus 2ab. This is a plus b whole square, right? So this a plus b whole square is what I have, and I'm interested in the value of a minus b. So a minus b is what? So to get a minus b, I'll go with a minus b square, because a minus b square I know is a square plus b square minus 2ab. If I add 4ab's on both sides and subtract 4ab, so if I will add 2ab and subtract 2ab on all sides, then I see that this is nothing but a plus b whole square only minus 4ab. Okay. But I already know this value. So this is just 289 minus 240. That comes out as 49. Therefore, I get a minus b mod as 7. Okay, moving on to the next question. So here S is given to us as a series. So what is this series given to us as? Let us write the terms. So the general term we can see is 1 plus. We can write this as summation of every time. 1 minus, it is 2 square, 4 square, 6 square. That means in general some 2r whole square into, we have 1, 3, 5, so on. That is something like 2r minus 1. This summation from r varies from 1 up to r is equal to 10. So this is the summation that is there. This is the summation that is there, which is given to us as, we will simplify this summation. So this is like 1 plus summation of 1 minus this summation. So the summation we can see is nothing but 8r cube minus 4r. This is from 1 to 10. This is also from 1 to 10. So all we have to do is just substitute the formulas for summation of 10 is just of 1 is just 10. Summation of r cube formula we know is 8 as it is outside. This is n into n plus 1 by 2 whole square. That's the summation formula. This was r square. So minus the summation of this is 4 into, and this is minus, so minus makes it plus 4 into 10 into 11 into 21 by 6. So this is the value. So if we simplify this, it comes out as 11 minus, I'm going to have this expression simplified. So maybe I can remove this minus out itself over here because I want to put it in that specific format. So this 8 is, I can see that this is just 4, not 4, 2, because this is 2 square, that will cancel off with this. And this is 10 into 11 square. So that is 110 square. And I've removed minus, so I'll get a minus out here. I'll get this as 140 into 11, but then I'll take this 2 inside with this. So this is what I have. So if you rearrange this expression, it looks like 11 minus 220 times 103. So that tells me my alpha and beta. So I have alpha value as 11. So alpha comes out as 11 and beta comes out as 100. And that is option number 2. Okay, let us look at another problem. So we want to find the number of solutions of this. You can see that x is just any real numbers. So this is greatest integer of x square plus 2 times of greatest integer of x. Because this 2 is an integer, I can remove it outside. So plus 4 minus 7 equal to 0. So this is just like greatest integer of x square plus 2 times greatest integer of x minus 3 equal to 0. So this is like a quadratic in greatest integer of x, or you can see that it is greatest integer of x plus 3 into greatest integer of x minus 1 is equal to 0. So this is going to imply greatest integer of x is either 1 or greatest integer of x is minus 3. If greatest integer of x is 1, this itself tells me that x can take values from everywhere, from x belongs from everything from 1 to 2. So here only I can say that there are infinite solutions. Because, or you can also have this x is from minus 3 onwards, so x can also belong from minus 3 to minus 2. So that's also saying adding up to more infinite. So in this case I'll have infinite solutions.